Hi guys, today inshallah we will explain the different states of matter and describe the kinetic molecular theory of particles and its assumptions. First of all, different states of matter include, according to your curriculum, solid, liquid, gas, and plasma. If we need to describe kinetic molecular theory of particles, what does it describe? This theory describes the behavior of matter in terms of particles in motion. It describes the behavior of matter in terms of particles motion. Means that it describes how the particles move. And it lists 5 assumptions for the molecular theory of particles. 5 assumptions for the molecular theory of particles. What are those? First, the theory says that gas consists of large number of tiny particles that are far apart relative to their size. If you look here, here are the particles. We have here the particles in gas form. You can see that the particles are very small comparing to the space they occupy. They occupy a big space, although their sizes are very small. These were the first assumptions. So the first assumption of the theory that gases consist of large number of tiny particles that are far apart relative to their sizes. So relative to the size or the volume the gas occupies. You can see here that we have particles of gas. Those particles are small in size, although they occupy a big space. The second assumption describes the movement of gas particles. And the movement explained in the term of collisions, that there are collisions between gas particles and between particles and their containers. And those collisions are completely elastic. Let's explain this point. Particles move continuously in all directions. Here the gas particles are moving continuously, colliding with one another and colliding with the walls of container. This collision is described as elastic collision. What do you mean by elastic? Elastic means that when the particles hit a wall, it will bounce back with the same energy. There is no any loss of energy due to collision. Normally there should be some loss of energy, but we are expecting that there is no any loss of energy. These kinds of collisions are described as elastic collision. Third assumption describes the movement of gas particles. saying that gas particles are in continuous, rapid, and random motion. So the gas particles move all the time. Gas particles can move all the time in all directions at random and at very high speed. So the particle can move in any direction randomly and rapidly. The fourth assumption, there are no forces of attraction between gas particles. So we are expecting that there is no any force of attraction between gas particles. This means that the particles can move free, they are not attracted to one another, no force of attraction. So we assume that they move random, rapid, continuous without any attraction or repulsion forces. The fifth assumption is that temperature of the gas particles or of the gas depends on the average kinetic energy of the particles. Depends on the average kinetic energy of the particles. Means that if the kinetic energy of the particles increase, if the particles move fast, the temperature will increase. And we expect that, not only in gases, but in matter in any other state. When you rub your hands, this kinetic energy, it produces a sort of thermal energy or heat energy, causing a rise in your body temperature. In the same way, we can expect that when the gas particles move all the time at very high speeds, when the speed of the particle increase or average kinetic energy increase, we expect that the temperature also would rise. Now we need to use the kinetic molecular theory to explain physical properties of gases with respect to expansion, fluidity, low density, compressibility, and diffusion. So we are going to use the kinetic molecular theory to explain the physical properties of gases in terms of or with respect to first expansion, and then we'll explain fluidity, density, compressibility, and diffusion. If we go to expansion, expansion means here, if you look at this picture, here the gas is expanding. The gas is occupying a smaller area of the vessel, only half the vessel, and it can expand to fill the whole vessel. This property, we call it expansion. Why gases can expand? Gases can expand because of assumption 3 and 4, which is assumption number 3 and 4, which said that particles move rapidly in all directions, assumption number 4, without force of attraction or significant attraction between them, in all directions without significant attraction between them. The second assumption for a gas is fluidity. As you know, Both of gases and liquids are described as fluids. Let's say why. Because the attraction forces between gas particles are very small, like in assumption number 4, or non-existent, so the particles can easily pass over one another. In this way, particles of the gas behave similarly to liquids. So both of gas and liquids are described as fluids. So we can say that the attractive forces between gas particles are very weak to hold the particles in a rigid structure. And that's why both of gases and liquids are described as fluids. The third property of gas is low density and high compressibility. Gas particles have very low density. Let's go to understand first what is density. As you know, density equal mass over volume. So when we say the gas has low density, this means that the volume is very large and the mass should be very small comparing to the volume they occupy. And this is the case in case of gas particles. Gas particles are farther apart than they are in any other state. This would increase the volume, so they are going to occupy large volume, although their masses are very small. Diffusion. Diffusion, ability of the gas particles to move randomly, let them diffuse. What is diffusion then? Diffusion means ability of the particles to diffuse or spread through another particles. Gas particles, if you have the gas particles are moving all the time randomly, and as they move, they hit the molecules of another solid or a liquid, or even another molecule of a gas particles, colliding them. These force of collision collectively lead to spreading of these molecules within the gas molecule. And this property, we call it diffusion. Again, so diffusion is ability of particles to diffuse through another types of particles. Here are the particles of the gas. They are very far apart. They are moving randomly and continuously. While they move, they hit particles of the solid here or the liquid, pushing the molecules everywhere. Then they will diffuse and become equally distributed within the liquid container or the gas container. So we can write here diffusion. This one belongs to assumption number 3, and it's described by the random movement of gas particles or in continuous random motion. So if we will explain the particles in the liquid phase in terms of kinetic molecular theory, we'll explain first the density of liquid. Usually they have relative high density. Why this happens? Because there are strong forces between the particles. If you look at the particles of liquid, particles are close to each other, and this means that there are forces that hold the particles. The, the forces that hold the particles increase the density of matter in the liquid form. Yes, yeah, that's true because density equal mass over volume. If the volume gets smaller, because gas particles are a little bit compact comparing to liquid particles are compact comparing to gas, this means that the volume is smaller and this is going to increase the density of liquid. Second property is relative incompressibility. Incompressibility, we can't compress liquid. It's very difficult to compress, and this is for the same reason, because the particles are very close. Particles are very close, so when you apply pressure, they will not get compressed. So relative incompressibility, this is because particles of the liquid are more closely packed than gases, and this makes them difficult to compress. Ability to diffuse. Gas particles are in constant motion, and that's why they can diffuse. Constant motion. As we have just said, they are fluids and they move continuously. Ability to evaporate. Gas particles can evaporate, and a very famous example is evaporation of water. Water of the surface, water surfaces on bodies can evaporate when they have enough kinetic energy to escape. So when liquid particles evaporate, when they get enough kinetic energy to escape into the gas phase. Escape into the gas phase or the gas state. Now we should use the kinetic molecular theory of particles to explain the physical properties of solids. Physical properties of solids. Also in terms of shape, volume, density, compressibility, and diffusion. Regarding shape, everyone knows that particles of solids have definite shape and volume. And this is because the particles are packed closely together. Particles are very close, so it's so difficult to change the shape or the volume of solids, although they expand a bit when the temperature increases. Secondly, density. Because they are compact, the particles are so close. This means that they'll occupy a small volume, and as density equal mass over volume, when the volume gets very small, the total value will increase, so the density will increase. So they have high density because of the same reason particles are closely packed, and secondly, high incompressibility. it's very obvious that you cannot compress solids because there is no space for particles to occupy. Alternatively, in the gas form, particles were very far enough, and this means that you can compress and bring all gas particles together, and in this case you are going to decrease the volume they occupy. But if you have already matter in the solid form and the particles are so close, it's impossible to compress or to let them occupy a smaller volume. Low rate, low rate of diffusion, and this is for the same reason. Particles are very small, they are in fixed position and unable to flow. So why solids have low rate of diffusion? Because of 1. Particles are in fixed position. Secondly, they unable to move freely, they just vibrate. And thirdly, because the particles cannot flow. Because diffusion needs particles to flow in order to move from one area to occupy another area. This is impossible in solids. I hope you now have clear understanding of the kinetic molecular theory. In the next video, inshallah, we are going to practice exam style questions. Thank you.